Hi Lana, hello and welcome once again to Lana's Coach. So we are going to look at the difference between a process and a thread, especially with respect to how the operating system functions. So this is a very interesting topic that will allow us to ensure that we understand what basically are the roles of a process and what basically are the roles of a thread. So if you are always interested in this kind of discussion, or you are joining us for the very first time, kindly always feel free to subscribe so that we reach the wider audience. All right, so before we proceed, kindly subscribe. All right, thanks for subscribing. Now, what is a process, right? Because this is a very unique term that's always used in each and every environment. Yeah. So, with respect to operating system, because that is a process, right, of a program that is being executed within a particular operating system or arrangement. So we all know that a process must include some kind of steps or phases, right? Like someone is going to ask you maybe what is a process of doing A, B, C, right? So you need to maybe follow some procedures. So that's the same thing. It takes some time to follow all the steps required to execute what? A particular program. So this particular execution of a program is what we refer to as a process, step or a procedure that is carried out in a systematic way. Now, I want to give you a typical example that we are going to use in this particular understanding of what a process is. Like, for example, if you're visiting our website, you will open a particular web page, right? Then you are likely to also open other tabs, right, when you are actually looking for additional information within our website. Now, when you initialize the first program, the first web browser, that could be seen as a process. But if you proceed and create additional tabs, then that could be seen as instances of an original process. Now, these instances of processes that you create when the original process is actually executing is what we refer to as child processes. Now, in this understanding, we are going to look at these child processes as threads, right? So another example, maybe that is going to make us understand the difference of these two terms, is that a process, we can look at it as a parent. Yeah. If you have a parent and then you have children, most likely you will be having a lot of duties to execute. So as a parent, you're likely to divide these duties to the respective children or that you have, so that they help you execute or carry out some tasks, right? So that's a similar thing that process does. A process, for it to execute multiple tasks, it needs the assistance of these child processes, and these child processes are actually what we refer to as threads, right? So each process contains its own memory. So for a process to be able to execute effectively, it needs to have its own memory. These are the crucial resources, right, that it should not share with any other processes. Now, the reason as to why processes should not really share resources with other processes is to enhance operating system performance. We don't want a situation whereby processes will maybe shut or stop because of lack of resources, right? So we are going to maybe proceed and understand more of the difference between the process and a thread. Now, a process has different states. Like, for example, when you are executing a particular process within an operating system, it must maintain some states. Like, for example, if you're creating a new process, for instance, that state of a new process is what we refer to as new, right? So when a process is actually being created for the first time, it creates a new state. And then we have the ready. Ready is a process that is ready to be launched. Yeah. So it is always waiting to be executed or to be allocated to a particular processor. Then we have the active process. It has the running state. Yeah. So this is actually the process that is being executed. And then we also have the processes that are waiting, right? Or they are in a waiting state. They could be waiting for a particular resource to be free, or maybe just to ensure that some kind of operation are happening so that they proceed. So that is a waiting state. And of course, the last state is the terminated state. This is after the process has already executed its process, or it has finished what it was doing. Then it can always be terminated. So these 5 states identify the various process stages that we can always have. And of course, we need to understand then, how do processes work? And remember, we are talking about this with respect to the operating system. So a process actually normally undergoes some steps. Like, for example, for a process to be executed or launched, it needs to be placed or loaded within a computer's memory, right? So the fact that the operating system needs to execute different processes, then it has to convert this particular process into some language that it can understand, right? So a program, as you had mentioned, or a process for that matter, requires crucial resources, right? So that it can be able to execute effectively. So these particular resources, as I mentioned, they are memory, they're the processor itself, right? This processor itself contains additional resources such as registers, right? Program counter, to ensure that we know how many programs or processes that have been launched. We need to have a stack and any additional resources that you're going to look at. So as we know, a register can have some set of storage address. A storage address is that particular label that we label the various processes, like the process ID, so that we identify the various processes. And of course, we need to count the execution of this particular processes. So we need to have the program counter that will maintain the track of the programs. And of course, we need to have a holistic stack that has information on the active programs, right? So all these will inform how a particular process work. And remember, when a particular program or process is being executed, then there's always some number of instances that we need to ensure that we understand. These instances, as I mentioned, are the child processes. We also have the features of process that we need to understand. Like, for example, for those of us who have seen how to maybe create processes using the Linux operating system, we normally have the fork function. Yeah, this fork function allows us to create our process. So we need to ensure that any process must and should exist within its own address or memory space. Very, very important. Again, each process should be independent and treated in isolation by any operating system. I think that we have already mentioned. Very, very important. Also, as processes must be able to communicate amongst themselves. Remember, there's a tutorial that I talked about how different processes communicate within a distributed system. So inter-process communication is very, very important. It allows various processes to share resources, or various processes to actually send and receive messages, right? So in looking at the inter-process communication, processes can be able to communicate either synchronously or asynchronously. So these are some of the things or features that a process should have. So it's not a must that they need to synchronize. They can always maybe asynchronize at any point. Then we need to understand what a thread is. Now that you have looked at what a process is, as I'd mentioned, the various instances of a process or the subset of a process are known as the thread, are commonly referred to as the lightweight process, right? So, for example, if you have a lot of tasks to perform as an individual and you require some help, you are likely to bring on board different people to help you achieve that particular task. So what we need to do is to have distributed task amongst the people who are helping you. So the same thing, a process can have different or multiple threads on what we refer to as multi-threading, right? And we can also find a process having just a single thread. So these particular threads can always share resources, right? Or can work independently based on how they are organized or what they need to achieve within a particular process. Now, the good thing with thread is that unlike processes, they can always be allowed to share resources within that particular process. So a process gets the resources, then share it amongst the what? The threads within it, right? So that's why all the threads within a process are interrelated. They talk to each other. You can terminate a process, but still you need to terminate the individual what? Threads within that particular process. So, however, within this particular process, as you had mentioned, they contain their own registers, stack, and counter. So this particular diagram shows both the multi-threads and single-thread processes. So as you can see the first diagram, we can see this process just has, or it has just a single what? It has a single thread. Then the second diagram, we can see a program showing process showing 3 threads. So that is a multi-threaded process. Now, what is the difference between these two? Of course, the number of threads, right? But as you can see that, for example, in a single thread process, this particular thread is allowed to share, right, the registers, the counter, and the stack, all that kind of what? Resources, together with the code, data, and files. In a multi-thread, however, each and every thread has been designated their own registers, stack, and counter, as you can see. So they don't really share these, because we need to count maybe how the number of times a particular thread has executed some task and so on. But you can see at the top, they are allowed to share the code, the data, and the files. Now, what then do we need to understand about these two processes, or threaded and single thread processes? That if you want, for example, to create a single thread process, it's going to be created very fast compared to the what? The multi-thread, right? Because it has different threads. If you want to terminate these two processes, again, the first thread that has a single thread is going to be terminated very fast, and so on. So those are just examples of differences between the two types of threads. So just like processes, how does a thread work? Now, a thread works within a particular process. That's what we need to understand, right? So whatever the operating system, or whatever the resources that the operating system assigns to a process, it's going to redistribute those particular resources to the threads, right? So for example, when a process starts, as is indicated, or the operating system will assign the resources to it. So each thread is going to really associate itself with the available resources. Threads are mainly used to improve the processing of an application, right? So the more threads we have, actually, the lighter the task of a process is, right? So, and of course, the more threads also will actually inform that a particular process will need to be given more resources to be able to maybe distribute to these particular threads. So multi-threaded process requires a lot of resources compared to that a single thread process. So here, when you have multiple threads within a particular process, a lot of things happen very, very fast, and this is what we refer to as context switching. Yeah. So here, process can be able to assign different roles to different threads so that they perform very, very fast. So if a single thread executes in a process, we refer to it as a single thread process. That's what you have already looked at. And if multiple threads execute simultaneously within a process, we refer to that as multi-threading. Now we have again different categories of threads or types of threads that we need to understand. We have those particular threads that are normally associated with the user, right? Like the application programs. When a user tries to use different application softwares, chances are they will be using user level threads, right? So here the threads are easy to create by the users, because the users are the ones who interact with these kind of what softwares, right? Of course, we have the other type of thread that is closer to the hardware, right? What we refer to as kernel level thread, right? So these threads are faster to create and manage, the user level threads, right? They are implemented based on the available user level libraries. Yeah, so we can create, as a programmer, you can create some system calls, right? So that they can be able to interact with the operating system. So each process, as you have mentioned, has its own private thread to keep track of the threads. The other category of the other type is what we refer to as the kernel level thread. So here, this is the inbuilt thread within the operating system. Actually, it's the operating system level thread. I can also call it like that, right? So these threads are complicated. They are not easy to create compared to the user level threads, right? And of course, we need to have a lot of procedural calls, a lot of invocations, methods to call, and ensure that these particular threads work accordingly. So here, kernel level threads are slower to create and manage as compared to user threads. We have already looked at that. So the thread table, or what we refer to as the register, is not present here, yeah, for each process. Yeah, basically because it's very, very difficult to understand, or rather to maintain all these particular procedures or the system calls that are being implemented within the kernel level thread. So, ladies and gentlemen, these types of threads can always be associated within a particular process. So it depends with what this particular process is meant to execute or achieve, right? Then we have the advantages of using these threads. I think we have already mentioned the advantages. First, they improve the performance of a particular process, right? Like ensure that you have the right computational speed, things are executed very, very fast. The ability of a process to have multiple threads will ensure that it executes tasks very, very fast. So that improves the performance, right? It also allows effective resource sharing. Yeah, we see that an operating system can allocate different resources to different processes, right? So it's the threads that will share these particular resources and allow this particular process to perform multiple activities or tasks within the same address. And of course, threads allows proper utilization of multiple processor architecture. We talk about parallel execution of programs, right? So this can be achieved when different threads actually carry out different tasks in parallel. So that is a very important activity that a thread performs. Then the time that it takes to switch between one task to the other, right, is very minimal, and that's why we talk about reduced context switching time. And of course, the simultaneous achievements that is being found when different tasks are being executed is really a very important task that a thread performs, and that's what we talk about concurrency. Concurrency here is achieved when a particular thread maybe is interacting with a thread in a different process without really affecting how the other threads or how the other processes are performing. Then we have the last one, which is actually tied to the third advantage, parallelism. So this is a technique that is normally implemented when different tasks are being executed in parallel within a particular process, courtesy of the threads. Then, what's the difference between a process and a thread? So, in summary, based on the definition, right, we have seen that a process is actually a program that is currently under execution, right, whereas the thread resides within that particular process, right, and is scheduled for what? Execution. Termination time, as a matter of fact, process will take a lot of time to be terminated. I think this we illustrated in the previous diagram, whereas the threads will take less time. Of course, same applies to creation time. Yeah, creating a process will need more time. Context switching, yeah, between process is more compared to how the context switching happens within a thread. And I think this is why a process with multiple threads is very effective and efficient compared to a process with minimum or few threads. And of course, interprocess communication happens very, very fast when you have multiple threads communicating with each other. So these are the key differences between a process and a thread. And I think the other one is the resource sharing capability that is enhanced, right, when you have a process and of course when you have a thread. So processes uses a lot of resources, but threads use some kind of fewer resources because they need to share those particular resources compared to what? The processes. The other resource is the memory, right? Sharing of this particular memory, for example, in a process is run in separate memory space, but for the threads, they can always share. So I think something to note here is that processes really don't share resources amongst themselves, but they ensure that the available threads share those particular resources. And of course, sharing of data. So I gave an example that you could be opening a browser, right, and have or create some instances of that particular browser. So this could create a good example of a thread and a process. So as you can see, we can have a process and of course the different resources within this particular process that are being utilized by the available threads, right? So we can see there's a stack there, right? And of course the interfaces that are provided for communication between a process and a process, what we refer to as the sockets, right? So we can also write some kind of program codes, yeah, such as the system calls that allows communication or inter-communication between the different processes. So a good example is when we have a client communicating with a server. So you can see here different of the two processes or the two threads within a process doing different tasks. One is generating a result, the other one is sending some kind of request to the server. A keen or a good thing to understand is that a server always have some kind of what? Many requests being sent to it. So as you can see, there are different requests, and these different requests are captured based on the different threads that are released by the client process, right? So for communication to happen within two systems, normally we require to understand how the process works, and that's why it's very important to differentiate between how a process works or functions and how threads support their functionality. So if you are interested in this concept of process communicating between themselves, kindly check on our previous videos that we talked about inter-process communication, just to learn more about asynchronous communication and synchronous communication. So I hope this one is an eye-opener in understanding the difference between the threads and process within an operating system. So should you have any recommendation, suggestion, or if you find that you need to help us understand more of these, kindly comment within the comment section so that you can always respond and share this particular information effectively. And for those who are interested in this kind of information or concepts, always follow our channel and don't fail to subscribe. All right, thanks.